Hello friends, welcome to today's episode of Problem of the Day series from the Leetcode. So today's problem is profitable schemes. I never thought that I'm going to design or solve the problem for uh, criminals that to make the maximum profit they can have. Anyway, so let's get started. So the problem states that we have group of n members and they have to do various crimes. For every crime there is a profit, that is profit I, and that requires that number of people, right? And overall what we have to do is that we have to find number of ways to make a crime, or you can say number of ways to have a uh, make money that is more than the minimum profit. So for example, here an example, so let's go draw this thing. So suppose that I have given n is 5, that means I have 5 people, 5 criminals, and total profit I have to make is say 3, and the group is that we have two people, 0 and 1, 0 and 1. So that means that if I do the 0th crime, I am going to make a profit of 2 and it will require 2 people. Similarly, if I am going to make this crime, then I'm going to make a profit of 3 and number of peoples are required is 2. Overall, that what we have to do is find out the total number of ways, and it requires 2 schemes. So if you take a look, is that we have to take minimum profit of 3, right? So this has a profit of 2, so that means that either I have to make this one, crime 1, to make a profit of 3, or we have to make a both crime 0 and 1 to make at least a minimum profit of 3, right? So the overall this looks more like an optimization problem, and in an optimization problem, the one approach which I usually take is that uh, to make a decision whether you can do it or not. So for example, if I have been given array 0 1 2 dot 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 n, they are actually profits, right? So that gives you the total number of crimes. So at any position index I have to make a decision whether you do it or you don't do it. If you do it, you take the profit, and if you don't do it, that's fine, you move on to the next one. In both the cases, then you move on to the next crime. So once you've reached towards the end, which is your profit dot length, and then you can see that whether I have made this much profit or not. If I have made this much profit, that means I have found at least one way to make a crime. So you increment the counter by 1. So that way, so this is like we can do it simple recursion way, recursive. Uh, the time complexity for this approach is going to be a bit higher because basically it will be polynomial time frame. So that means that for every index, you are going to make a decision, do it or don't do it. That means that I have 2 options here, then I have 2 options here, then I have 2 options here, 2. So overall, this gives you the complexity of 2 to the power n, where n is the total number of crimes. But it could be a good start to solve the problem. Alright, so let's get started. So we'll start by creating a simple recursive function that we are going to call. Let's call it uh, simple profitable scheme. Just let's copy it, right? And what we need to pass on this in, so as we discussed here, so we are going to start with the index. So we'll be passing our integer index, that on which crime you are working on. Then what is my current profit that I have made, and the second is that number of people that has been involved in the crime, because these are the 3 restrictions we have in this function. we also need these parameters like group, profit, and so instead of passing it directly, I am just going to create a few global variables. It will just simplify my code. So I am going to create these variables like minimum profit, the group, group, profit, and total number of people involved, and let's initialize them with these values, right? And then I'm going to call this my helper function. So I am going to start with my index, which is 0. In the start I have profit of 0, and in the start I don't have any people involved, so my count is 0. Okay, and we are going to return the result from here, right? Sounds good. Now let's work on the helper function. So if I have reached at the end of my profit array, that means that we can make a decision whether we found a way or not. So if my index is equal to profit dot length, right, and if my current profit is greater than or equal to my minimum profit, that means that I have found at least one way to make a crime. Otherwise you just return 0, that there is no way to do that. Alright, now I have option 1, that don't do the crime, don't do this crime. If you're not doing this crime, that means that now I am going to work on the next crime. So that is index plus 1. My profit has not been changed, and my number of people involved, it has not been changed. Okay, now the second option is let's do the crime. Okay, to do this crime you must be having sufficient number of people in hand. So that means that if my uh, people that I have already been used plus number of people required to this crime should be less than or equal to n, that is total number of people, right? And if yes, then let's do it and make a profit. So then you go on the next one, which is index plus 1. My profit has been changed, so that means that now I have made the profit of current profit plus plus profit of index, right? And I have used some people to do this crime, so I cannot use in future. So people count plus group of index, right? And then this is total, and then you return the count from here. All right, sounds good. Run. So this work fine for the smaller cases, but it will definitely fail for large number of sets. You get TLE basically. Sounds good. Now as our the pattern continues, so if you can take a look that we have, let's try to see. So basically it's an optimization problem, and we'll see, you can prove it basically that they have some overlapping problems. That means I am doing the same calculation again and again with different values. So what I'm going to do is like using the memoization to cache the result and use it when asked for it again. So here now we have three variables in the equation: index, current profit, and people count. So basically we have to create a three-dimension array. So let's create a three-dimension array here, and let's initialize it with -1. One important part here is that what should be the size of this memo, right? So if you look at the problem, we have some constraint. So one is that, okay, I have the group length of 100, so we can create that means that maximum it could be 101 people involved, or there could be 101, sorry, 101 people maximum. And total number of crimes is also, so where is I? Profit dot length is group dot length, and group dot length is 100. So that means that we have maximum 101 crime possible, right? The interesting part is the profit. Since minimum profit is less than or equal to 100, but the profit could be anything, right? So it could can keep on increasing and increasing. So there is pretty hard like to find out that what is going to be my maximum profit would be. So one thing, this is where I have took the hint, is we will try to keep the profit maximum of 101. We'll see how we do that. So we created a memo and then initialize it with -1 so that we know whether we have calculated or not. So three loops for three-dimension array, 101, and initialize everything with -1. Okay. Now coming back here, so now when I'm calculating it, after this step, like we'll check whether we have solved the problem with these values or not. So that we can do with this. So memo, index, current point, people count. So -1. If it is not, that means we have already calculated, return it. And then here, after doing the calculation, we will set it again. The one way is the problematic comes is the mod. So we'll take the mod here, equal to mod, and then and then we will return this value. Okay, so now there is a one very interesting part here which I actually have to take the hint, is this thing. So this continuously keeps on increasing my profit, right? And that's why our memoization array will be overflow. So a technique for this is like to keep the profit minimum, because what we really need is the minimum profit at the end to make a decision here, right? So instead of passing this, what I'm going to do is that math.min of the current profit, the new profit, and the minimum profit. This one. This way will help us to limit the profit to be 100 so that we can fill it in our memoization array, right? And then let's submit it, and that works. Sounds good. That's good for today. Hope you have liked this video. If yes, please like the video and subscribe to our channel, and we'll see you tomorrow. Thank you. Bye.